Welcome back, grade 12. Now, in part 2, we are going to now to look at a question where we are required now to calculate the amount of mass deposited. So, in part 1, we're calculating the average current that is flowing through. So, now we are going to calculate the amount of the mass of the substance that deposited. We are still on the electrolytic cell. So I try now to draft a question that is going to help us. So I'm going to read through the question and show you what is happening here. This is also a November question. I saw it on the previous papers. So the question here says, the diagram below represents a simplified cell used for the electrolysis of concentrated chromium 3 chloride. Here is a chemical formula. Electrode R and T are made of carbon. So this is electrode R, this is electrode T. Inside we have this concentrated chromium chloride. So they said the net reaction is 2CrCl3 giving us 2Cr in solid form plus 3Cl2 in gas. So if you go to the right here, they said now the graph below, not drawn to scale, represents the changes in the mass of the electrode T during electrolysis. So this is the mass in the y-axis of the electrode, the mass deposited. Then in the x-axis we have the time in hours. The mass initially, if you see, it was 2.2 grams. Then for a certain period of time it increased up to x. We don't know what is the final amount of mass after 10 hours. You can see there is 10 here. So after 10 hours the mass is x, which we don't know. Now the statement here says a current of 2.5 amps passed through the cell for 10 hours. Calculate, number 1, the total charge that flows through the cell during this time. Number 2, the value of x as shown on the graph. This is total of 9 marks. So we need first to find the amount of charge that flow through the cell, and then we find the amount of mass that was deposited. So I'm gonna make one calculation for all of this. So I want you now to listen very carefully. The first thing that you must always do, go check the ratio. This is CrCl3. That means that there are 3 chromiums, there is 1 chromium which is C3 plus, which reacted with chlorine. Remember, chlorine is in group 7. Now this 3 plus means that this chromium needs 3 chlorines. It wants to give 1 electron to each chlorine. So you need 3 chlorines to react with this 1 chromium. That's why the chemical formula is CrCl3. Meaning to say that there were 3 chromiums, there was 1 chromium with the oxidation number of 3 plus, meaning to say that it wants to deposit electron in 1 electron in 3 chlorines. Yeah. So that means that we have a Cr3 which will be reduced now by 3 electrons to become Cr in a solid form. If you go to your table 4b, this is what you are going to see. So here is your table 4b. Now there are 2 half reactions of chromium. There is this one and there is that one. So unfortunately, we are not looking at this one. We are looking at the one with the chromium in a solid form that donates 3 electrons and now is oxidized to become Cr3. So we are looking at this one and we are not looking at that one. So if you look at the ratio here, the chromium in a solid form, it is oxidized to become chromium in solid form is oxidized to become Cr3+. What is the ratio between the chromium and the electron? That is the first question that you want to look at. So the ratio here is 1:3. The ratio is 1:3. Yeah, here is it. The ratio between the chromium and the electron is 1:3. As you can see, 1:3. This is the first thing that you need to identify before you answer these questions. The ratio. Then let's go back now to the question. So a current of 2.5 amps passes through every 10 seconds. So we do have the current, we do have I, and we do have delta T. So they want to know what is the total charge that flows through the cell during this time. We want to find first Q. And then what is the value of X as shown on the graph? This is X, and we know X is the mass deposited. So here we want to find the mass. So we want these two things, the charge and the mass. So let's look at this. Okay, this is the information that we have. So I said here, this is our half reaction. This is our reduction half reaction. So what is the ratio from this reaction? The ratio 1 chromium yields 3 electrons. So the ratio is 1:3. This is the first thing that you need to discover. Now this is what they gave us. They gave us the current flowing through is 2.5 amps for 10 hours. But you need to know that the time must always be in seconds. So how many seconds are in 10 hours? So we know that there are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. So we need to quickly punch this on the calculator. So we have 10 by 60 by 60. So we have 36,000 seconds. So we have 36,000. So that is the time. So we want to find the amount of charge and want to find the mass. So I'm going to make one calculation here, or I'm going to make a sequence of calculations which will lead me to my mass, the mass that I need. But remember on the graph, the initial mass they said is 2.2 grams. So we must find now the final mass for the period of 10 hours. So what I need to do here is that I need to say, in order for me to find my mass, the mass that I'm going to get here, I'm going to add, I will find the mass, and then on the mass I got from the calculation, I will add the initial 2.2 grams so that I can get my total mass in grams. So there is amount of mass that I will calculate, then I will add 2.2 to it to get the total mass. Now this is what I want. Okay, let me give you now a map of what we are going to go through. So the first calculation that we must do is to find, we need the mass of the chromium. The mass of a chromium is the number of moles of the chromium multiplied by the molar mass. This is the first calculation that we are going to do. Now, remember this mass is what we are going to add 2.22. We need to find this and then add 2.2. Then we will get our total mass in grams. But we need this now, the number of moles of the chromium, because we already know the molar mass of the chromium from the periodic table. Now, how do we get the number of moles? That is calculation number 2. The number of moles of the chromium, how we are going to get it? So the number of moles of the chromium, I said, we need to find the number of moles of the electron, the ratio here. To get the number of moles of the chromium, we must know the number of moles of the electron, because the ratio is 1:3. So whatever we are going to get on the number of moles of the electron, we will divide by 3 to get the number of moles of the chromium. That is calculation number 2. Then calculation number 3, we ask ourselves, what is now the number of, what is this number of moles? We need this number of moles. What is the number of moles of the electron now? The number of moles of these electrons, we know that it is the number of particles, or we need to know the number of the electrons divided by the Avogadro's number. Avogadro's number. So in order for us to get the number of moles of the electron, we need the number of particles of the electron divided by the Avogadro's number. But the question is, how to get this number of particles or the number of electrons? So that means that we need to find now the amount of charge. We need now to find the amount of charge. Well, remember, the number of particles is equals to Q divided by QE. Now, the number of particles or the number of electrons is equal to the amount of charge divided by the quantization of charge. But how to get the amount of charge? Then the amount of charge, Q, is equals to the current multiplied by the change in time. So this is what they gave us. They gave us the current and the time, 10 hours. So we know now the current and the time. We can get the Q. After we get the Q, we substitute it here. We divide by 1.6 times 10 to the power negative 19. That will be our number of particles. When we get the number of particles, we substitute it here. We divide by Avogadro's number, which is 6,022 times 10 to the power 23. That would be our number of moles. Okay, I think to save time, let us just quickly go through it. So to find first the amount of charge, we say it's the amount of current, which we know is 2.5 amps, multiplied by the time. We say the time is 36,000. So this is 2.5 multiplied by 36,000. So we get the amount of charge, which is 90,000. So the amount of charge here is 90,000 coulombs. Then number 2, we said we have to find now the amount of particles. Remember, the number of particles or the number of electrons is equal to the amount of charge divided by the charge on the electron. So we do have the amount of charge is 90,000. So we're going to divide that now by 1.6 times 10 to the power negative 19. This is Coulomb, this is also Coulomb. So we're going to find a pure number there. So that 90,000 we divide by 1.6 exponent negative 19. So we get now the number of particles, which is 5,625 times 10 to the power 23. 5,625 times 10 to the power 23. This is the number of electrons, or the number of particles. Now, calculation number 3, we said now we have to find the number of moles of the electron. We do have the number of electrons. Now we find the number of moles. The number of moles, okay, let me just say the number of moles of the electron, we know it is equal to the number of particles, is the number of particles divided by Avogadro's number, divide by Avogadro's number. So what is the number of particles? It is 5,625 times 10 to the power 23. Divide that by the Avogadro's number, which is 6,022 times 10 to the power 23. So we get now the number of moles. So we divide that now by 6,022 exponent 23. Now we get the number of moles, which is 0,9341. 0,9341, 0,9341 moles. Now, this is the number of moles of the electron. Now we need to find out the number of moles of the chromium. We set the ratio there between the chromium and the electron. It is 3:1, or 1:3. So if the number of moles of the chromium is, let me put it this way. If you want to find the number of moles of the chromium now, we need to divide now this 3 divided by 3 and 1 divided by 3. We divide by 3 both sides. Then we're going to have 1:1/3. So that means that the value that we have here, which is 0,9341, we're going to divide it here by 3. 9341. We will divide it by 3. So we divide now this by 3. So divide now that by 3. So the number of moles of the chromium now is 0,3114. The number of moles of the chromium is equals to 0,3114. 0,3114 moles. Now we do have the number of moles now of the chromium. So we are in calculation now number 4. Calculation number 4, we said now we find the mass. So the mass now, the mass of the chromium is equals to the number of moles of the chromium multiplied by the molar mass. Remember, on that answer we're going to add 2,2 grams. Okay, let's quickly check the molar mass of the chromium. I think it's this one. So the molar mass of the chromium is 52. Here is it. So it's 52. So to find now the mass of the chromium, we said number of moles of the chromium times the molar mass, and we add that 2.2. So the number of moles is that 0.3114. We substitute it here. The molar mass is 52. Then don't forget to add that 2.2 grams. So let's multiply these two now. Multiply there by 52. Then we get 16,19. Then add 2.2 on that one. Then the total mass now is 18,39. Now we take two decimals, 18,39 grams. This is the final answer of the mass of the chromium. Yeah, I hope you can follow through on these calculations. They are beginning to be very easy now. So yeah, that was the last calculation. So I'm gonna put it in order. So I'm gonna say this was calculation number 4. That is calculation number 5. Yeah, you just need this to know these 5 step calculations. Either you want the mass or you want the current. You remember on part 1 they required the current. So on this one, on the first one they gave you the mass, they said find the current. On this one they gave you the current, they said find the mass. So you need to know both ways. If you want the other one, you have to start. If you want the mass, you have to start on the current calculation. If you want the current, you have to start on the mass calculation. So yeah, here is it. Step 1, find Q. Step 2, find number of particles. Step 3, find the number of moles of the electrons. Step 4, check the ratio between the chromium and the electrons. Step 5, we find the mass. Yeah, so this is the end of this question. It was a 9-mark question. So now we're gonna move to part 3, where you have to find, I think, the percentage purity or something. Then I'll do that one. That will be the last one.